One of my favorite activities on the planet is eating. In fact, I go out of my way to try a new food at least once per week. Someone who took this behavior to an extreme was Scott Cole. I came across Scott on the data science game show Sliced, and the data he collects blew me away. He meticulously cataloged hundreds of burritos that he ate around Southern California. From the looks of it, he carried a ruler as well as possibly a scale with him to every restaurant he ate at. To honor his commitment to food, I thought it'd be fun to use this burrito data for a project. Today, we'll be making a burrito dashboard to help people compare the various burrito options that are available in San Diego. Fortunately, Atoti, the sponsor of this video, makes it easy for us to create dashboards that are customizable and digestible for technical and non-technical people alike. In this project, I'll show you how I go about building this dashboard and learning this new tool at the same time. I highly recommend exploring new technologies through your projects. That is the single best way to get comfortable with expanding your capabilities. Okay everyone, this is what we're going to be building today. So as you can see, we have a couple gauges here. This is for the Yelp score of the restaurants. This one is for the average Google score of the restaurants. And this is a scatter plot where we compare the Google score and the Yelp score. So higher in the top right corner means that both restaurants, the restaurant on both platforms was scored very high. So our top right is probably the better restaurant groupings here. The color coding is for the different neighborhoods that the taco or burrito shops are located in. There's quite a few. And then each of the individual dots represents one restaurant. So a little different way to visualize this. You can start to see, hey, how do these compare? And we can filter based on those as well. So in the bottom here, we have radar charts for each of the locations, each of the restaurants, and it has the approximate, like shape of what you're getting from the burrito. So if the cost is high relative to a lot of the other burritos, it's expensive. If there's a lot of, if the fillings is high, it means there's a lot of fillings in that one, length, mass, and volume, etc. So I thought that was a pretty cool way to describe the burritos. We can also choose, specific ones if we want to, and compare and contrast there. So we can look at these two ones and see how differently they're scored. Something like this is interesting when they have a significantly lower Yelp review than Google review. I personally am very partial to Yelp. That's what I mostly go off of. I don't trust Google reviews at all. So this is a way to kind of compare them and evaluate them in a fun and simple way. So let's get going on getting started and how we set up our environment for this new project. Okay, so the first thing we should do is download the data. So go to kaggle.com. We'll just type in burrito. And the burritos in San Diego should pop up. We download this and we'll just put this in whatever local directory we're using to also host our notebook. Probably the easiest thing is I'll put all of this on GitHub, including the data, and you can just clone that repo so you can get working a little bit faster. You can either use clone from the command line or you can just download it from the GitHub location. But yeah, this is the data set we'll be using. And the next thing we want to do is to create a new environment. So creating a new environment is a pretty good software engineering practice. So essentially what we're doing is we're creating a new virtual machine on our computer to run this analysis. And we'll only install the libraries that we really need for this analysis on that machine. That means that we don't have a ton of extra dependencies. We don't have a lot of extra files and bloat that we're not really going to use for this. This will make it easier for us to hand this analysis off for someone else to use it. It also just, again, eliminates a lot of that redundancy. We can do that in a couple different ways. I'm going to be using Anaconda environment to do this. We can also use Docker. We can use a pip environment, but I really like Conda. I've made a couple tutorials on how to set all this up if you aren't familiar with that process yet. So I highly recommend checking those out. I'll link them in the description and in the top right corner. So how we'll do that is we're just going to go to the Anaconda prompt. Here, I'll try and make this a little bigger so everyone can see. There we go. And atoti has some pretty good documentation on how to make sure atoti is installed in a new environment. So we're just going to copy a lot of this here. So we're just adding the Conda Forge channel to our Anaconda, our like regular Anaconda environment. We're adding the atoti channel. And then we're just going to create a new environment. So this is the one that really matters here. So we're going to Conda create, and the environment, we're going to name it atoti. We could name this anything. I called the other environment burrito, but atoti makes sense because we're going to be using that for our analysis here. The next thing we're going to do is activate this environment. Once this is done here, it should only take a second. Great. We're going to Conda activate atoti. Boom. Now we're going to install all the packages we're going to use for this analysis. So again, we'll copy and paste. We're also going to use pandas and scikit-learn. Right. So after we run that, we should have everything we need to get this project up and running. This will probably take, 5-10 minutes. So I'm just going to kind of cut that part so you don't have to bear with me for that. Okay, so now that that is finished downloading, let's just open up a notebook. So this will just take us to our Jupyter Lab environment. Hopefully it doesn't take too long. All right, we can just copy this local address here. Okay, so we're gonna want to just create a new notebook. We probably want to go to the correct file directory. And so we're gonna create a new Python file. I absolutely hate light theme, so we're gonna change it to the dark theme. And then we can actually get started here. Okay, so the first thing that we're going to do is we're going to install, or we're just going to load in our packages. So we'll import pandas as PD, import numpy as np. I actually don't think I use numpy, but I include it almost always because it can be useful. Atoti as tt, and we're also going to use regex, import re. Next, we're going to load in the data. So as you can see, the data is right here, burritos.csv, whatever it might be. So we're going to do data frame equals pd.read csv. 1, 2, 8. And then let's just look at some of the columns. So let's see what we have here. So we have the location, what the burrito is. Let's dive into this a bit further. We're going to look at the first 5 rows. So I guess this is the type of burrito that we're looking at. So the location is the burrito shop. The neighborhood, we have the date, address, the URL, we have Yelp reviews, Google reviews, if they got chips, the cost, and then a bunch of different topping data. I think for the most part, we're not going to be looking at what was in the burritos. These seem to be like 0 and 1 values or nons. So I'm not super concerned about those, but let's look at the general shape of the data to begin with. So we're going to do do you have to describe? And then we can see the distributions of a lot of these different columns here. So we can see that the average Yelp score is 3.89. The average Google score is higher. That's consistent with what I see. The average burrito cost is $7. I'm assuming this is in US dollars. And it looks like hunger is on a scale of 0 to 5 with the person. Mass is in grams. Density is in grams per milliliter. The length of the burrito, it appears to be, I would assume, centimeters. A 20-inch burrito would be very large. The circumference, I'm also assuming, is in centimeters. We have volume, like the quality of the tortilla, the temperature, the meat, fillings, etc. Those are all subjective 0 to 5 scale. So a lot of this is looking really interesting. They have salsa, wrap, overall information. Something we definitely want to be looking further into, starting to visualize and use some more tools here. So when looking at the columns, one of the things that I see is these parentheses, and I don't think atoti or any of these programs really play that well with parentheses. So I just want to remove those, and we're going to use a regular expression to do that. Admittedly, I had absolutely no clue how to do that, so I just essentially searched Stack Overflow. So Python remove data in parentheses. It took me quite a bit of searching, but I did find a pretty useful resource. Let me see if I can actually find it here. It was on Stack Overflow, as you would imagine, but this is what I came to. So what I did is I just did this. So this takes out everything within these types of brackets. Made a lot of sense. I didn't have to read too much into it, and I just integrated that into my code here. So what we can do is we'll just do df columns. All right, so we know what that does. It creates the columns, but we want to set it equal to what we just copied there. And we want to replace that with nothing, right? And then we also want to remove any additional spaces, so we'll just use strip for x in df.columns. And in theory, that should remove those parentheses. So again, I didn't have to do anything crazy, but I was able to remove the parentheses G for mass and density gram/milliliter. That's not going to be integral to our analysis. It's honestly just going to confuse us. So that was a pretty easy adjustment we could make. Unfortunately, it still does look like there's a colon in here. So there's like meat filling. And I think we should just replace that with perhaps just something else. Let's just use an underscore. That's a more common notation. So we're just going to do something similar. We'll do x.replace, and we're going to replace a colon with an underscore. And we're still going to strip everything to make sure that there's no additional spaces or anything like that. Let's try that now. So let's check it out. It looks like we replaced that meat filling colon right there with something a little bit more usable. Okay, so now that we've resolved that little small issue, just cleaned up the column names a little bit, we want to look at null values and see if that's going to be a problem with this data set. So an easy way to do that is df is null any. And as you can see, it looks like these are sort of keys in the data frame: the location, burrito, and date. But neighborhoods, addresses, all of these other values are null. So something we can do, df dot is null dot any dot sum, and it'll tell us how many are null in each of these columns. Yeah, exactly. So we can see, 384 for zucchini I don't know exactly how big the data set is, so we can just do df.shape 0. Yeah, so it looks like 97% of the burritos do not have zucchini. And if we just do df.shape, we can see that there's only 385 samples there. So we know that a lot of those for the toppings are probably going to be null. Looking at, maybe once we start getting to bell pepper, carrots, cabbage, sauce, those aren't going to be super interesting for this dashboard. Frankly, since I already built the dashboard, I know we're not going to be using those to begin with, but it could be something that would be useful to use if we're building a model to predict burrito price or something like that. That might be a fun follow-up project for anyone who wants to explore this data just a little bit more. Okay, so let's legitimately start creating a dashboard now using atoti. I think it makes sense for us to go through a little bit of the documentation, just walk through sort of a little tutorial that they put together. To me, this is one of the best ways to get familiar with how everything works. So what you're going to see me do is I'll create a session. That's something that essentially make sure that this works within our environment. It looks like we can also read in just a CSV or potentially even a pandas data frame to create a table within atoti. And then we can operate on the table in a very similar way that we would operate on a pandas data frame. Next, we create a cube, and it looks like a cube is just a way to format data in atoti. So we're going to be using some of these. Honestly, I don't know how to perform with these that well yet, so it'll be a bit exploratory on my end as well. But it looks like these cubes have a hierarchy, they have different levels, and they have measures. And I expect we'll be working quite a bit with measures. It seems like measures are just how we evaluate numeric data using this platform. There's a really good description of how this all works on the tutorial and in the documentation, so I'll just make sure to link that below. For right now, let's try to get our hands dirty and see if we can have some fun creating some visuals here. So from atoti, let's create this session. And what we're going to do is we're going to add config equals user content storage. And this will allow us to save our work. So this creates just a new file content, and it allows us to access it at port 9000 on our computer. Again, for when we create the dashboard, if we want to be able to share it or expose it to someone else, this is how we would do it. So this might take a second or two here. I also want to do just a little bit more data manipulation. So something you can see here is that hunger, for example, is normalized to 5, right? Mass, cost, these things, like there's a $25 burrito. If we want to be able to compare cost to hunger or something like that across the scale, we want to normalize it. So we want to make, in my mind, everything from 0 to 10. That'll just be easier to digest, especially for those radar charts that I'm planning to create. So in order to do that, we're first going to do from sklearn.preprocessing import min max scalar. Did I spell that correctly? Looks like I did. Great. And we're gonna, nope, I did not spell it correctly. Wow, spelling not my greatest strength today. Recent processing. There we go. I'm virtually certain that's spelled correctly. We'll do scalar equal to min max scalar. Good, that worked. And then we're gonna just create a burrito fares norm. So this is just a small data frame of the data variables that we plan to normalize. So df location. We want circum volume length mass and cost. Perfect. So oh, forgot a comma. Huh. Classic. Okay, so as you can see, we have our values for each of these. There's definitely going to be some null values in here. We can just do like is null sum. Try that again. As you can see, for mass, there's very few full values. So it looks like there's 20 where we actually have the mass, but we have the volume and the length and the cost of most of them. We're talking about like 2/3 of the data for circumference, volume, and length. So I still think it's worthwhile to have mass in. He obviously didn't take the scale to every restaurant he went to, and that's totally okay. That would be even weirder than the ruler itself. So we're going to normalize this by just taking this. So we take B, we'll just create B norms, and that is going to equal to scalar.fit transform Burrito Vars norm, right? And that'll scale it from 0 to 1, and we'll just multiply it by 10, so it'll be from 0 to 10. And that should be more comprehensible to humans. We could just leave it 0 to 1. I just think it would look nicer in our visual if it's 0 to 10. The next thing that we're going to do is we're going to create a bunch of new columns in our data frame with these data points. So we'll just take all of these like this. And we're going to add norm. So this is the normalized value for these. And this will just add 5 new columns with the normalized information to the current data frame that we have. I also spelled norms wrong. Good. Norms, there we go. Perfect. By doing that, if we do df.columns, we can see we now have these new columns for us to use that for. I think it makes a lot of sense to do it that way. In order for us to get these in the radar chart, we do have to change the format of that data. So we might as well do that now. We're just getting ready for when we actually start using the tool. Let's just go through and do that. We're going to use melt from pandas. And so what that does is it reorients the data frame. So we have all of these as columns, right? What melt will do is we'll create one column that has all these values. So it'll be either circumference norm, volume norm, length norm, mass norm, whatever it is in that column. And then it'll create one more column that has the value associated with that. So what the actual, for example, cost was. So we'll dramatically reduce the number of columns, but we'll increase the number of rows quite a bit. And that is just easier for us to work with some visualization tools, namely Plotly, which is what atoti is based off of. And I really like using Plotly. This is, in my mind, a great thing that they're building off a really good existing framework. So we're going to call this Burrito variables. And we're going to use PD melt, use data frame, and I'm just going to reset the index. So we have a column that has like the index values that currently exist. Next, I'm going to do, we have to make ID variables, and those are going to be location and burrito. We could also put date in there if we wanted to, but I think this will be sufficient. And then we want to use the value variables here. And those are going to be what we had just described up here. And I'll show you in just a second what this will look like when we actually print it out. So you'll see what I mean when we reorient it, right? So we have the location, burrito, and then we have what variable it is. So again, all of these are now in this column, and the value associated with the value of the circumference normalized is now here. So we have significantly more rows. We have 5 times the number of rows, and basically, all of these wrapped up into one column. So we have 4 less columns than we did before. Let's start using atoti now. We can actually start dragging and dropping data. That's something I really like about this tool. So rather than us having to do this completely programmatically, we can have some fun with a pretty nice graphic user interface. Okay, so let's initiate some of our data, and you can see more about how we do that here. So we create a cube, and the cube just automatically adds dimensions to our data and creates this relational structure. So we can do cube equals session dot create cube, and we do that from the burrito table that we created up there, right? And that's just from our data frame. Now we also want to add the hierarchies, levels, and measures to the data frame. So they do that here. So H is initialized as hierarchies, L is the levels, and M is cube measures. When we do it like this, we can go in and manipulate these pretty easily in code. So that's something that'll make a lot of sense for us to do now. It's kind of, I'll show you what I mean when we can go in and manipulate these. We're doing this mostly with measures anyway. So let's just go in and create those, and I'll show you a little bit more of what I mean. So H equals cube dot L equals cube dot levels, and then M equals cube measures. Cool. And so something we can do, like, let's create a new measure. So a measure is going to be 5, right? And this is going to equal to 5. So M, if we look at this again, we could say M5, and it will return the codified measure. And when we use the graphical user interface, this will make even more sense. So let's start doing that. So you do session.visualize, and then we'll just call this like experiment. We'll just call it exploration 1. Okay, so this is where the fun begins. So now when we click on this, we have access to all these, and they're in drag and drop fashion, effectively, right? So I can take, let's do something like the average Google. Let's do something like where's location? Okay, here we'll take location in the rows, and then we'll look at the length of the burrito for each one, right? So, if we're looking at this, we can potentially, I think, sort this, right? Sort descending, and we can see, okay, mi asador, Mexican and seafood. So I guess asador is probably, I thought pescador is fisherman. I don't know what asador is, but so we can see they have a pretty long burrito, which I guess is probably a good thing, or it might mean that it's not necessarily wrapped correctly. So, that could be something to evaluate as well. We could make like, another measure. So what we just did, I made that 5 measure, right? So we can add, you know, there we go. So we can add 5 down here, and it just shows you that made a new column of all 5s, right? Let's try to make another measure, and let's do like M, L, len, X, and then we'll do wrap, right? And that's, come on. And that's equal to M times M L-E-H. Probably learn to spell. All right, let's create the session again, and we'll see if our new variable showed up. I forgot what I called it. So len x wrap, and then we'll just add this down here, and we can see that maybe if we sort by this score instead, we'll get different values about the best wrapping by the length that we have. So you can see El Torito Foods, you know, maybe they're doing a better job wrapping when they have a longer burrito, and that's something we care about. So a pretty simple use case for how we would create a new variable and have a little bit of fun with that. As you can see, it's really easy using atoti to create these pivot tables. It's also pretty easy to make some graphs. So let's just make a simple, well, let's create another visual. So when we create these visuals, this is pretty slick. We can publish them in the app, and that lets us use a completely graphical user interface without any coding. And we can go in and, like, I can just take this exploration 1 that I just did and put it into a dashboard, right? So for every new visual that we create, we can essentially do that and just drop that right into a dashboard, which is a lot of fun. So let's go back here. Let's create a new session. And then let's call this one scatter plot. And what we're going to do here is we're going to make that first top right graph that I showed you earlier in this Burrito dashboard. We're going to make this one where we can compare these different Google and Yelp reviews based on the neighborhood. So first thing we're going to do is we're going to go down and select the scatter plot. Pretty easy one. The next thing we're going to do is we're going to go and find the Yelp mean. We're going to go up and find the Google mean. And then we're going to divide them, separate them up by location. So that is going to go into the split by column, all right? And then for the actual neighborhood, we will put that into color. And then we have the exact graph that we did before. Now to just add it to, we'll just call the scatter plot neighborhood, Yelp, Google. Super short name that I've created there. We'll right click it, publish it in the app, and then when we go over here, it should show up in a little bit here. And we'll just work off this new dashboard that I created. Let's call this one Burrito Final. Sweet. So cross my fingers, scatter plot neighborhood Yelp, I can put it in here, and we have this beautifully located here. Exact same plot as we did before. We can rename it however we want, but this is pretty good for our use case. Let's now try to create that other radar chart visualization. So we did some fancy footwork up here where we manipulated, where is it? Where we created these burrito variables norm. And then we added these columns here to the data set, and then we created these burrito variables in this melted format like this, right? What we want to do is connect this back to the table that we've created in atoti. So I'm going to show you how to do that really quickly here. So we're going to just do burrito var table, and that's going to be session.read pandas burrito variables. That's what we created up there, table name, and I'm going to call it burrito variables. I'm going to do keys equal location burrito, and then variable. So those are just the column names that we created there, right? And then we can initiate that. And then the last thing we have to do is we just take our burrito table and join the burrito var table. So now there's a relationship created between our existing burrito table data frame and this burrito variable table. So we have a hierarchy, we can use them both in the same dashboard, which is pretty nice. The next thing we want to do is we just want to make sure we create a measure for the values that are created in the column under variable. So what we'll do is we'll do m value equals tt ag mean burrito var table value. All right, so this is essentially just going to aggregate the mean of all of those and create this value measure. We also are going to create this ag value equals to tt dot ag mean m value scope equals tt dot scope dot origin L location L burrito L variable. Okay, now that I'm done typing that out, let's walk through this and explain it just a little bit better. So where does this value come from, right? So we created this value column up here when we were using burrito variables. So we just want to make sure we alias it as a measure, as a measure in our atoti instance. Here we're creating an ag value, and that's also going to be a measure. And what we're doing is we're taking that value that we created here, and we're creating a hierarchy using location, burrito, and variable, so we know they're all related, so we can filter on them and do whatever we need to related to them. So here we actually define the levels this measure aggregates along. We don't create new levels or hierarchies. I'll add that. And then let's do session.visualize. Final. Here we go. And now let's do it to it here. So we're going to go down here to the radar chart. So I want to create a bunch of different radars based on different locations. So we're going to put the location in the horizontal subplots category. We're not really going to see anything yet. Next, what we're going to want to do is create the axes, right? And the axes should be based on, it was variables, right? Yes, it should be variable. Oops. So we should be able to go down here and we'll see variable. So when we add that in, we see that on a bunch of these different axes, we have variables. That's what we're looking for. And then up here, we want to go and fill in the actual values. So we'll go and we'll find value and we'll add values there. And so as you can see, like some of them, they're nans, so it's not going to be filled in. It's not going to be a complete thing. But each of these radar charts makes it makes up one location. In the future, I'd have to do a lot more experimentation, but it'd be great for us to be able to see multiple restaurants, multiple locations plotted on the same scatter plot. But that was something in the short amount of time I had fooling around with this that I could not end up figuring out. So what we're going to do is we're going to publish this to the app as well. We can go to the app and then we'll add it in. So this is our Burrito Dashboard final. What we already have is the scatter plot. So we wanted that up here, right? And then the radar chart final, we're going to put down here. And then we wanted to add in a couple gauges. So let's work on those. We should be able to do most of that actually in the complete graphic user interface. So let's have a little bit of fun with that. And let's look at how we actually build the gauges themselves. So for here, we can either do a KPI. So KPI is just like big numbers that are relevant. You know, you could just do like the average cost, right? Oops. Where did it go? Oh. Average cost, there we go. $7.05. But I thought a gauge would just look a little cooler. It's like halfway to a pie chart, but I still think it looks pretty neat. So we'll go over here. We include the first gauge, and it's really easy, obviously, to drag and drop. How did this get in here? I meant to do the other widget. Sorry, guys. The radar chart, right? There we go. And then there we go. This new gauge, we'll go up with that. Perfect. So let's see what the gauge chart actually needs here. So we need a value. So our value is going to be, let's do the Yelp one first. So it'll be the Yelp. And so we can see it's 3.9. We want a minimum, which is 0. And it looks like the maximum here is going larger than what is possible in Yelp. Yelp and Google have a cutoff of 5. So we want to add a maximum. We can also set a goal, which is like the little red tick like we had before. To me, that'll be pretty fun and easy. Let's do just a little more code to get those, and then we should be able to integrate that. So all we have to do is we actually already did one of those things. We have the measure, which is 5 that I created a while ago, just to use an example. But that ends up being pretty useful for the maximum, because the maximum does happen to be 5, right? So let's see if I can find A, B, C, D, E, F, 5. It's going to be the maximum. And it looks like we know that the minimum is going to be 0. I don't even have to do anything there. My cutoff for Yelp, I'm a bit of a snob, is 4 stars. Or not 4 stars. Yeah, 4 out of 5 stars. So I will begrudgingly eat somewhere like at 3.5, but it'd have to have some serious good recommendations from someone I know to get there. So let's just make that 4-star cutoff. So we're just going to make a measure here. So M for, here we go, equals 4. Pretty simple and straightforward. And then we're going to add 4 right here to the goal, right? Pretty easy. We have our, so this is Yelp score, mean. And then we want to go down and create one more gauge for our Google score. So we'll just put it right there. And let's do, the value is Google. And same thing, our maximum is going to be 5. Oh, nope, sorry. Our maximum is going to be 5, not 4. The least I will eat at a Google review, because they are a bit more granular, is around 4.2. I do not trust Google reviews for food at all. So I'm going to just make sure we add that in to our gauge. So we're going to do M for Google. And this is going to equal 4.2. We'll do 4.25. I feel more comfortable with that. So for Google, we'll put that as the goal. Perfect. And so, you know, we can move these around a little bit, make them just a little bit bigger, look a little prettier. Does not need to do that. We can kind of go that way. And then once we like take it full screen, if we want to analyze things more, or we can go and present, and it'll make sure everything looks really good. So the last thing that we want to add is just some filters. So for example, in this one, I don't really want any Yelp scores of 0. I don't think that makes sense to include. So we'll just add one more adjustment to that. Well, it actually looks like they're already filtered out. Let's just add in an additional filter here so that we can choose what restaurants we want to look at. So if we go down, we can go to location, and then we can choose the specific locations that are relevant to us. So let's just choose like 4 or 5, and then we can compare them directly using the scatter plot or using our radar charts, and we can see the aggregate of all of these different ones. So this is going to be, again, Yelp mean, Yelp score mean, Google score mean, Burrito radar scores, and then Google versus Yelp review scatter. Cool. So again, we have this pretty neat dashboard we were able to create fairly quickly. In theory, right, we could have done almost everything drag and drop style here. I thought it was fun, you know, more for my audience to have some coding integration to build that over there as well. I'll put this code in a GitHub repo. I'll also make sure that they host the dash on the GitHub repo and in the atoti like library, which I'll link to. But hopefully you found this enjoyable. Hopefully you learned something about, 1, how to pick up a new tool, 2, how to build a neat and interactive dashboard, and 3, that you don't have to just be reliant on specific tools for programming or for BI, like some of the stuff that's out there. There are hybrids that are really accessible to a lot of people, and that, you know, maybe for someone who's coming from a data analyst role, they could have a lot of fun with this and also pick up some of the coding and some of the infrastructure at the same time. This is a really cool meet in the middle area. Also, if you're interested in burritos in San Diego, this is a great way to learn about the kind of landscape there and pick a pretty good restaurant. So I know that if I go to San Diego anytime soon, I will be scoping out a couple of these spots. Thank you so much for watching. I hope you, again, enjoyed this, and good luck on your data science journey.